Q3243-1. To properly purge water from the fuel system of an aircraft equipped with fuel tank sumps and a fuel strainer quick drain, it is necessary to drain fuel from the A. Fuel strainer drain. B. Lowest point in the fuel system. C. Fuel strainer drain and the fuel tank sumps. The correct answer is C. To properly purge water from the fuel system of an aircraft equipped with fuel tank sumps and a fuel strainer quick drain, it is necessary to drain fuel from both the fuel strainer drain and the fuel tank sumps. Water can accumulate in the fuel system due to condensation or contamination, and it is important to remove this water to prevent it from reaching the engine and causing potential issues. By draining fuel from the fuel strainer drain and the fuel tank sumps, any water present in these areas can be effectively purged from the system. 2353. During pre-flight in cold weather, crankcase breather lines should receive special attention because they are susceptible to being clogged by A. Congealed oil from the crankcase. B. Moisture from the outside air which has frozen. C. Ice from crankcase vapors that have condensed and subsequently frozen. The correct answer is C. During pre-flight in cold weather, crankcase breather lines should receive special attention because they are susceptible to being clogged by ice from crankcase vapors that have condensed and subsequently frozen. Crankcase vapors contain moisture, and in cold temperatures, this moisture can condense and freeze inside the breather lines, leading to blockages. It is important to inspect and clear the crankcase breather lines to ensure proper ventilation and prevent pressure buildup in the engine. 3239. If a pilot suspects that the engine, with a fixed-pitch propeller, is detonating during climb-out after takeoff, the initial corrective action to take would be to A. Lean the mixture. B. Lower the nose slightly to increase airspeed. C. Apply carburetor heat. The correct answer is B. To prevent detonation in an aircraft engine, pilots should follow several guidelines. Firstly, using the correct grade of fuel is crucial, as different engines require specific fuel types with the appropriate octane rating. Maintaining a sufficiently rich mixture helps to cool the combustion process and reduce the risk of detonation. When operating the throttle, it is important to open it smoothly to avoid sudden pressure changes that could trigger detonation. Additionally, keeping the engine temperature within the recommended operating limits helps prevent overheating, which can contribute to detonation. Some aircraft are equipped with an automatically enriched mixture during takeoff and climb out to enhance cooling. Lastly, if the engine temperature is becoming a concern, lowering the aircraft's nose to gain airspeed can help decrease the engine temperature by increasing airflow. By following these practices, pilots can minimize the risk of detonation and ensure safe engine operation. 3221. Excessively high engine temperatures will A. Cause damage to heat-conducting hoses and warping of the cylinder cooling fins. B. Cause loss of power, excessive oil consumption, and possible permanent internal engine damage. C. Not appreciably affect an aircraft engine. The correct answer is B. Excessively high engine temperatures will cause loss of power, excessive oil consumption, and possible permanent internal engine damage. Engine components have specific temperature limits, and when temperatures exceed these limits, it can lead to detrimental effects. High temperatures can result from factors such as inadequate cooling, insufficient lubrication, or excessive power settings. Monitoring and maintaining proper engine temperatures are crucial to ensure safe and efficient engine operation. 3221-1. Excessively high engine temperatures, either in the air or on the ground, will A. Increase fuel consumption and may increase power due to the increased heat. B. Result in damage to heat-conducting hoses and warping of cylinder cooling fans. C. Cause loss of power, excessive oil consumption, and possible permanent internal engine damage. The correct answer is C. Excessively high engine temperatures, either in the air or on the ground, will cause loss of power, excessive oil consumption, and possible permanent internal engine damage. When engine temperatures rise beyond acceptable limits, it can have severe consequences for engine performance and reliability. Loss of power and increased oil consumption are indications of engine distress, and continued operation under high temperatures can lead to permanent damage to internal engine components. It is important to address high engine temperatures promptly and take appropriate corrective actions to prevent further damage.